Hey guys, I want to talk to you real quick about chapter 8.1, which is solving quadratic equations. Although I won't actually, well, maybe I'll show you one example of solving a quadratic equation using one of the methods. I just want to make a video about completing the square. So I'm really excited about this video in particular because completing the square is an abstract topic. Like, a lot of people don't really ever like to get used to it, but I think that if you watch this video in advance, you can really become a pro at completing the square so that solving quadratic equations is a lot easier before we even talk. So if you finish this video and practice a bunch before class, then I think you can get really good at this. So like I said, we want to talk about completing the square, which is just a technique for creating a perfect square trinomial. So let me just remind you that if I had something like x squared plus 2x plus 1, this factors to be, let's say this factors to be x plus 1 times x plus 1, which is x plus 1 squared, right? And so the idea is this is a perfect square trinomial. It's a trinomial that factors into a perfect square. So we want to be able to complete the square, take any trinomial that we start out with, and complete the square, make it a perfect square trinomial. Like the questions will ask, what if I have x squared plus 8x? What has to be added to the end of this trinomial? What number has to be added in order to make it a perfect square trinomial? Like if I add a 1, that's no good. It's not even factorable. If I add a 2, same thing. So the question is, what number should I add to make it a perfect square trinomial? Well, the answer is 16. One way to think about it is, what number what number plus itself gives you 8. So 4 and 4 gives you 8, so that when I multiply them I do get 16. But that's not always the easiest way. So it's a good way to start thinking about it, to see why I have perfect square trinomials, but it's not necessarily going to work all the time. So let me list out the steps for completing the square, and then I'll show you a bunch of examples. Alright, so the idea is that if you're given a quadratic equation, ax squared plus bx plus c, where a equals 1, so if I want to, I can kind of even just come and take this a out, so that a has to be equal to 1 in order to complete the square. There can't be anything in front of the x squared term. Then the steps are to, well, there's 3 of them. First, take the middle term, b, divided by 2. Like in this case, if I divide 2 by 2, I get 1, and then you have to square whatever you get when you divided b by 2, so that in this case you also get 1. It's not really an enlightening example. But if I go back to the x squared plus 8x example, what number completes the square here? What number makes this a perfect square trinomial? Well, if I take 8 and divide it by 2, I get 4, and 4 squared gives me 16. So like I said, 16 was the number that created the perfect square trinomial. 8 divided by 2 gives you positive 4. Well, positive 8 divided by positive 2 gives you positive 4. And then 4 squared, positive 4 squared, is 16. All right, so we're going to try these steps. The third step is to balance the equation. This is when we're solving quadratic equations. So if you want to, you can kind of erase that and forget about it. You just need to divide by 2 and square that number in order to actually find the number that's missing in order to complete the square. So like if, for example, I was given x squared plus 22x, the question is, what number do I have to add in order to complete the square? Well, what I'm telling you is take positive 22 and divide it by 2 to get 11, positive 11. Positive 11 squared gives you 121. So that notice x squared plus 22x plus 121 factors to be x plus 11 squared. I do want to bring up that the sign is a little important. I'll show you some shortcuts in a little bit, but the main reason I'm including the sign is, or worrying about it so much, is like if I had x squared minus 10x, I want to know what number should be added in order to create a perfect square trinomial. Well, again, if you take negative 10 divided by 2, you get negative 5. Negative 5 squared gives you positive 25. Take b divided by 2, and then you take that number that you got and square it. So what I'm telling you is that x squared minus 10x plus 25 is your perfect square trinomial. I mean, in this case, the answer is just 25 because that's the number that should be added. But if you look at this trinomial, it factors to be x minus 5 squared. So the sign is important. The two numbers that multiply to positive 25 and add to 10 are negative 5 and negative 5. But maybe you're starting to see a little bit of the shortcut. The shortcut is that whatever number you get when you take b and divide it by 2 will also end up to be on the inside. So in this case, I divided positive 22 by 2. I got 11. And squared it to get 121. And that factors to be x plus 11 squared then. Now you don't really need it in this case because you can just say the two numbers that multiply to 121 and add to 22 are 11 and 11. And same thing here. When you take negative 10 divided by 2, you get negative 5. So after completing the square, it factors to be x minus 5 squared. Again, though, I don't think you need it because x squared minus 10x plus 25, that's a nice polynomial that we can factor pretty quickly. The problem is, well, there's two problems. One, the answer may not always be divisible by 2, or b may not always be divisible by 2, I'm sorry. So that if I had x squared plus 19x, well, let's just make it 9x. Then, to complete the square, to find the number that should be added here to create a perfect square trinomial, I have to take positive 9 and divide it by 2. Well, that doesn't simplify. It's just positive 9 divided by 2. And when I square it, 9 divided by 2 is 81 over 4. So the number that creates a perfect square trinomial is 81 over 4. We're going to do a lot more with that in class today. But again, what I want you to see is that x squared plus 9x plus 81 over 4, that's a perfect square trinomial. Now this one's really hard to tell. How do you factor what two numbers multiply to 81 over 4 and add to 9? We've never had the factor with fractions, so this might be kind of intimidating. And I can't fraction bust, it's not an equation. So I'm a little worried that I don't actually know if this is a perfect square trinomial. Well, what I'm telling you again is that this shortcut, whatever I got when I divided whatever I got when I divided b by 2, is going to end up to be my factor. X plus 9 over 2 squared is x squared plus 9x plus 81 over 4. Think about it. 9 over 2 times 9 over 2 is definitely 81 over 4. But what happens if I add 9 over 2 plus 9 over 2? I get 18 over 2, which is exactly 9. So 9 over 2 is the number that multiplies times itself to give you 81 over 4 and adds to just be 9. Now, I don't really think I would have came up with that if I didn't know the shortcut. So you can have all kinds of answers here. Maybe I have something like x squared minus 21x. And I want to know what number should be added to complete the square here. Well, again, negative 21 divided by 2, that doesn't simplify. So negative 21 divided by 2 squared. We have a list of squares, and we did do 21 squared, so you probably know it. It's 441 over 4. If I add 441 over 4, that gives me a perfect square trinomial. But then x squared minus 21x plus 441 over 4 factors to be what? What do you think? It's x minus 21 over 2 squared. Again, I'm taking the sign each time I divide, because how do I know if it's going to be positive or negative? It all depends on this middle sign here. So even if you didn't take the sign, it should match here so that the two add up to negative 21, but multiply to be a positive 441. Okay, so that's all you need for the problem of the day. You can stop the video there if you want. I'm going to show you one more thing just in case you need it later. Like if, for example, I had a leading coefficient that's not 1. That should be kind of intriguing to you. Like, what do I do if I have 2x squared plus 6x? And I want to create a perfect square trinomial here. You can't complete the square because a is not 1. So usually what we do is we take the 2 out and just complete the square on x squared plus 6x. 3x. Make sure you take the 2 out of both of those terms. So then you see, okay, well, I can complete the square just on x squared plus 3x. That's no problem. I take positive 3, I divide it by 2, and then I square it. Positive 3 divided by 2 squared gives me 9 over 4. Here's the problem, though. I'm adding the 9 over 4 on the inside of the parentheses. The inside of the parentheses is a perfect square trinomial now. It factors to be x plus 3 over 2 squared. Right? So completing the square just on the inside, that was nice, but the problem is that's not really what I'm adding. This 2 belongs to everybody. It allowed me to complete the square just fine, but technically if I multiply this 2 back through, it's 2x squared plus 6x plus 18 over 4, which reduces to 19 over 2 if you just cross simplify. The point is then that the number you really have to add to both sides, or the number that you really have to add is 9 over 2. Why? Because I added 9 over 4 on the inside of the parentheses, but that 2 belonged to everybody, so it just becomes a 9 over 2 to complete the square. Now, when you factor it, like I said, you have a perfect square trinomial here. You just got to be careful because you're not really adding 9 over 4, you're really adding 9 over 2. Because factoring out that 2 changes it. So that's going to be a big deal later. I don't want to go too much in depth and start losing you, but there are cases where the a is not 1 and you have to do all kinds of special things. Maybe I'll show you one more because in that case the actual 2 factored out. But what if I had 2x squared plus 5x and I wanted to complete the square here? Now I feel stuck because 2 doesn't come out of 5. But the truth is you can still factor it out. How do you factor a 2 out of a 5? You just leave it as 5 over 2 and complete the square with 5 over 2. So that should be strange, or might be strange if you haven't seen it before. But think about it. 2 times 5 over 2 is 10 over 2, which is 5. Or the 2's cross cancel to just give you a 5x back out. So the point is that you got to take x squared plus 5 over 2x and complete the square with this thing. Well, how do I take 5 over 2 and divide it by 2? Dividing by 2 is the same as multiplying by 1/2. 4 divided by 2 is 2. 4 times 1/2 is also 2. So the dividing by 2 and multiplying by 1/2, those are the same thing. This gives me 5 over 4, which when I square gives me 25 over 16. So the point is that I'm adding 25 over 16 on the inside. What do you think I'm really adding to the whole expression? Well, that 2 belongs to everybody, so really I have 2x squared plus 5x plus 25 over 8 if I distribute through. So I really added a 25 over 8 to complete the square to create a perfect square trinomial, but it just looks like, I guess you could say, in disguise because it's on the inside of the parentheses. See if you got the shortcut down. What do you think this factors to be? 2 times what squared? It's 2 times x plus positive, the middle term is positive, plus 5 over 4. 5 over 4 times 5 over 4 gives you 25 over 16, and it adds to 5 over 2. Then when you distribute the 2 back through, you get this polynomial that you started with. So we're going to deal with equations. The third step is balancing the equation. You can't really just add a number to a polynomial, but if you have an equation, you could add it to both sides of the equation. If you do have a polynomial, you could always add it and subtract it. That's an option too. So I'll probably make a new video for the future chapters and talk about all of that. But if you have questions, let me know. Otherwise, see you guys in class.